Alright, so let's identify basic facts and characteristics of the Tropo Satellite Support Radio, better known as a TISR, or the AN/GRC-239. That is the nomenclature for it, description, number-wise, or the Jerk 239 is what I refer it to. Again, you guys know about the block tests, how many you have to get right. You got to get 28 to pass. Preferably that you're in that only missing a couple if you have to miss them. We look at the RF test transmissions AFSC. Big thing is they're still, the Jerk 239s are still out there. They're just far and few between nowadays. It is being replaced by something called the P2P 600 or P2P 700. The Papa Tango Papa is referred to point to point, and if I read the specs on it, it should come up to about 123 miles maximum range on it. A far cry from what this TISR can do. Let's look at it. So we're going to look at the purpose, operating characteristics, types of traffic, the equipment, and lastly signal flow, which we'll do tomorrow. Signal flow is about a 2-hour expedition. That's the reason I'm looking at starting at 8 o'clock in the morning. We're going to look at this purpose of it, which is a full duplex. Full duplex meaning you are working with two separate frequencies. One's transmit, one is receive. It is lightweight and field tunable. That's questionable as far as lightweight because all the cases, transit cases, require a two-person lift. It is not lightweight in any sense that way. But once you open the cases, one person can do it. It does connect between, multiplexers or, any type of line of sight radios that you can connect to it. It is designed for quick deployments, and that's where the transit cases come into play. I will tell you that it does have front protection covers, so when you do have that adverse weather, it is protected and rain won't get in. We look at the operational characteristics, and I'm going to take you through the tech order later on. It is a frequency range of 14.4 to 15.25 gigahertz. Power is 25 dBn at 316 milliwatts. The IF frequency, and this is the receive part, is 70 megahertz. Look at the maximum range. This is problematic for those of you who can't figure out the less than or more than sign, like WA here. All I know is when I look at that, I know it's less than 25 miles, and I'll explain that when we get into the tech order. It works off of conditioned diphase and pseudo NRZ. Yeah, pseudo meaning kind of like regular NRZ. As far as I can tell when doing a research on it, I don't know. I just think somebody was doing their doctorate thesis and that's what they came up with. And of course we've got analog or digital voice or wire. There are two assemblies, and you can see right above me you have an RF assembly and a baseband assembly, and you can barely tell in this picture that there's two in there, but they're separate, and it mounts on a tripod or a mast or a pole. We'll get into that in just a minute. The baseband assembly can be rack mounted, put on a tripod or any flat surface like a table. The RF assembly And this is where things get a little sticky. You got a 50-foot mast. Oh, that is the CTM-15. And if you hadn't noticed in the Block 4 room, the CTM-15 does have things like the AN/GRC-239 printed on the mast. That means it's part of the Tisser assembly. By the way, the CTM-15 comes out of the UK, and same with the Tisser unit. It does mount on a tripod or a pole, depending on what you need it for. This is what the baseband assembly looks like. It has 5, count them, 5 LRUs. That's line replaceable units. You can look at the front panel of this and determine that there's only 4 that you can truly see, but realistically the breaker panel and power supply are behind the same far right hand side LRU. Each one of these looks like 4 screws on top and bottom, so you can, once you unscrew them, you can slide them out and grab the card and replace the card. We have an order wire, which is far left. That's 1 LRU. We have the transmitter right next to it, and then the receiver, and then the power supply breaker panel. The RF assembly has 3. They're behind the front panel. This front panel actually has hinges, so when you unscrew them, the hinge folds out and you can get back in there to remove and replace the 3 cards. It has a 1 or 2 foot antenna. Actually, it's a 1 or 2 foot dish. The baseband assembly can be connected to it with either the 2-foot cable or a 150-foot cable. And the reason why you have the 2-foot is because of the tripod. Makes things easier just to put both of them on that pan held tilt assembly pan. And then you have the 150-foot, which if you need to mount that on a mast, you can. Or if you just keep the RF module on the tripod, you can relocate the baseband assembly. Those are 2, or put it on a pole. That's the other one. Now, with the 150-foot, and I'm going to give you an example of what you could see out in Block 10, is sometimes the instructors that are out there, they want to be in a nice, cool tent, so they'll tell you to put the baseband assembly in there, and you're scratching your head going, I don't understand. Well, get the 150-foot cable, and it'll work. There you go. Transmit and receive must be at least 200 megahertz apart, and that's because of the diversity system. Again, they say 2 antennas. Realistically, there's not 2 antennas. There's only, the antenna is actually in the back of the portion where the waveguide fits into. The antennas, which they call dishes, are the 1-foot and a 2-foot. Now, the reason why we got these 2 variants is because of the distances. The 1-foot antenna is, it has 31 dB of gain in addition to the RF assembly, and can be mounted on a tripod, pole, or mast with the RF assembly. The 2-foot antenna gives you 37 dB of gain and mounts only on the tripod or pole. It does not mount on the CTM. CTM is going to come with some extra guy ropes. So when you do mount the RF assembly on there, it has a wind load of approximately 70 miles per hour, not like the regular CTM, which has a wind load of 20. So with that in mind, the 2-foot dish is what prevents it from being mounted on a pole, and you end up making it a sail, and that's the reason why you don't want to put it on a mast. So again, 2-foot antenna will not be mounted on the mast. We're going to be looking at transmit path, receive path, standby loop back, and order wire tomorrow morning. So we're going to change this over to the tech order. You should look through your C's and D's if you're able to. You're going to look at E3 ABRD 133. Not disregard that. Handout's considered 3 Delta 133-7-9 Bravo, and it should say something along the lines of TISR on it. So if you want to follow through with this while I'm going through it, it will probably help you when you need to find certain things in the tech order when you're searching through your homework. Let me pull this up to where I got my first highlight, because I've highlighted this. You can see where in General Information, Chapter 1, I have 1.3.1 types of traffic highlighted. And this is some very key points that you need to be aware of in the tech order. And it talks about what the TISR is going to carry. In this case, a 3 volt peak-to-peak conditioned diphase waveform. That's CDI. That's what it's saying. Its range is from 0.072 to 4.608 megabits per second. We have the next part where it says analog voice order wire or digital voice order wire. There's that other segment. And by the way, the order wire is considered our, in other words, maintenance, auxiliary channel, not to be confused with the CDI. Okay, so that's a separate channel on there. We go down just a little bit more. It says the radio set can carry 6.144 megabits pseudo NRZ signals. This one is extremely important. Let me explain. This is the only place in the tech order that has the word pseudo NRZ. It is assumed by the manufacturer that you read the capabilities and equipment limitations on this, and that is considered part of it. Now, why didn't they put pseudo with all the other places that will have NRZ on it? Well, there's a very good reason. The company saved, tens of thousands of dollars by not printing the word pseudo after this first place. We asked the manufacturer why they didn't put it in, and they said, well, we saved that much money just because we didn't print that word, which costs an extra 2 pages per tech order. You got to understand, those extra 2 pages times thousands of tech orders being printed, that's a lot of money to a company. So that's the reason why you only see it here in Chapter 1.3.1. Every place else that you see NRZ, it's assuming that you read this part and you can label it as pseudo NRZ. Whoops. The next part is 1.3.2 typical deployments, and I just highlighted Alpha, Bravo, and Charlie, where it talks about the mast, the tripod, and the pole mount. 1.3.3 radio accessories. That is stuff that is included in your transit cases that you have the alternative of using. For example, you can use the 150-foot cable or the 2-foot cable. It just highlights too the middle part of there where it talks about the receiver of 70 megahertz. I wanted to point that out. And then down at the last part, it says radiation of RF energy is via either 1 foot or 2 foot antenna. Again, that's your dish. Second line after that is the can set up for either the horizontal or vertical. And it just gives you an idea of what it's used with or for. Of course, it is going to go through and show you different configurations that it may use, and as far as the deployments are concerned. Now, we get to 1.4 equipment configurations. You can see that 2, 3, and 4 under 1.4 shows you the differences between the 1 foot antenna and the 1 and the 2 foot antenna and where it can be put at. You can see number 2, it only says the 1 foot antenna diameter antenna attached to the RF assembly atop a 50-foot mast. Whereas 3 and 4 both say 1 and 2 foot antenna when you mount it to a tripod or pole. There you have it. Then of course it goes into the tripod case, the RF assembly atop the mast. Now, when we come into breakouts, excuse me, or storage cases. This first case is an all-metal case. I consider it to be the heaviest of the three. It contains the RF assembly and the baseband assembly. Excuse me. But it has, I'm not sure if you can see number 8, which is the electronic console case. In that part, which is normally on the back side of this case, it will have in the pictures a handset, headset, 2-foot cable, and the power cord. That's it. So you have everything to power up your TISR, as well as make the connections between the baseband assembly and the RF assembly, and being able to talk to the distant end, as well as talk between the RF assembly and baseband assembly. This is the next case, which has the 2-foot and 1-foot antenna, as well as the waveguides. I say antenna, those are the dishes. You'll see number 5 and 6 where it says accessory kit and antenna transit kit or case. This particular section in 5 and 6, well actually 5, houses the guy ropes for the antenna or the mast. It houses the section to put the RF assembly on top of the mast. As you know that with the AT197, in order to get it on top of the mast, it came with the connector with it, and you slide it down, twisted it, and then you let it drop down and lock into place. Well, it has the same thing for when you set the RF assembly on it, except it comes with a halyard, and that halyard is to give it, elevation, because you can adjust the top part with the, from what I understand, the guy ropes to where you can twist it to get it in the correct azimuthal. Excuse me. It also comes with 2-foot stakes and not the 1.5-foot stakes. So they can go in deeper into the ground. That's the reason why you get that 70 miles an hour loading. And then, of course, this gives you more insight. There's that number 6, which is the antenna tilt assembly. Excuse me. And the cable reels and everything else and so forth and so on. Now you have the tripod case. So that's the third case. So you have the baseband RF case, which is all metal. Then you have the 2 green large cases. Do not try to attempt picking them up by yourself unless they are empty. You'll probably get yelled at if you try to pick them up by yourself and they have equipment in it. Do not do that because you'll pull your back out. You do not want to... You want to conserve your energy if you're doing 20 or 30 years here because work smarter, not harder. Because you don't want to be like me and have to have surgery on your backside because you've not done anything stupid but had accidents where you've had injuries to the back, and this can be one of them if you're not careful. Tripod case comes with the mounting plate where the RF assembly and baseband fit on. Then you got the pan head tilt assembly that makes your azimuthal, which is 360 degrees, as well as your tilt or elevation. And of course, the tripod you can adjust to make it level, because it has a leveler, bubble leveler, just like you have on the CTM. This gives you an idea of, this is on page 1.9 or 1-9 in the tech order. I don't know what it is PDF. PDF says it's 22. But you can see where we have the CTM and all of its glory in the guy ropes and the stakes and the 150-foot cable, you know, connecting it up to the RF assembly and so forth and so on. Even the halyard. This gives you an overview of what you're going to see out there if you ever have to put it up with the mast. This is what it looks like when you put it on the tripod. Again, if you look right above me, it looks almost identical to it, except the picture that I've got up there is colored. We have the front portion of the RF assembly. Now, one of the things that I'm going to go through real quick, like when you get out in the lab, there is a major problem that we are trying to alleviate, and we have a lot of people that want to put ones in the first thumb wheel. Well, if you look at this picture, or even the colored picture, you will see that the one is on the outside of the thumb wheels. Why? Because if our frequency range goes from 14.4 to 15.25, the tens of gigahertz never changes. And it's the far left number. The other part of that story is if you look at the first thumb wheel on the far left, it should only deviate from either a 4 or a 5. It should not go to 6, it should not go to 7, it should not go to 8, and so forth and so on. It should only do a 4 and a 5. Why? Well, that's because when you look at 14 to 15 gigahertz, it only changes from 4 to 5. The last 3 digits, or BCDs, or encoder, or thumb wheels, notice I changed the name a couple times there, so start getting used to that. Your thumb wheels on there will go from 0 to 9 on either one of those thumb wheels. Now, down below what's called the transmitter frequency, you'll see 2 lights. One is a channel error light, the other is a summary alarm light. Is it possible that you can go outside of the range of 14.4 and 15.25? The answer is yes. If you wanted to select a number of 15.3, you can do that. Why? Because that second from the left, that will go anywhere between 0 and 9. So if you're doing something at 15 and you get above the 2 and go to a 3, you just went outside the capabilities of that equipment. what's going to happen is that channel error light will illuminate. We also have a meter far left hand side. We have some switches right underneath of it. A switch to select either transmit power plus or minus 12 volts. We can look at our receive signal level on the meter, and we can also see something where it's EXP. This one is very sensitive and should only be used when your tissers are really far apart. And what that is doing is you're going to need that to figure out where, you're going to get an estimate of where the other tisser is. And if you can't see the receive signal level on the first one, you got to go to the EXP RSL, because then it's even more sensitive and you should be able to pick up some signs, and then you can tweak your dish either elevation wise or azimuthal wise until we can get it up to where you can peg it, or at least that's what I call it, peg it to one side and be able to switch it to regular RSL so you can tweak it in even more. Bottom left hand side, you'll see the receiver frequency and a knob underneath of that. This is called a cat's eye. This is old stereo technology. There is a tape on that rotary dial that you can see with all the frequencies on it. The idea is you're going to twist that knob and tune it, because it's a tunable filter, to the desired frequency that you want to receive. Most of you will remember what I just told you, and when it says to enter in your frequencies, you're going to be provided a cut sheet. It'll have the frequencies on it, both transmit and receive. The problem is the thumb wheels is where everybody gets screwed up. Why? Because we normally give you the transmit frequency first, and what happens? Everybody puts it into the top thumb wheels. Well, the problem with that is it's not transmit, it's receive. It's reversed of what the cut sheet is telling you. But also what we'll find out is most people will forget about tuning their filter to the receive frequencies, and then they go, well, why in the world can't I talk to the distant end here? Well, probably because you didn't adjust the filter. Normally it only takes about one time and everybody starts to remember at that point. Carrying on, we have the dish. There's the 1 foot, here's the 2 foot, and the waveguide. Here's the baseband assembly. Again, it's a little bit better picture. It's not colorized, but it gives you a indication, and I'm going to go through this when we do signal flow, in how everything is going to work on it and associate it with the information on the signal flow to the front panel, and vice versa. You can see that 1.5.2 is where I got the information from when it talks about wind loading up to 70 miles an hour. Again, the mast, tripod. Then we get into leading particulars. Okay? It will give you the whole set itself. Then it'll give you the RF assembly and baseband assembly. Can you imagine 16.5 pounds being put on top of the CTM-15 and lifting it 50 feet? I don't know about you, but that's going to be tough.
Easy, sir.
Yeah. If you're well versed in lifting weights, you're probably going to be able to do that. So next up we have capabilities and limitations table. This is an important table here. It dictates the frequency range, the RF output, which leads credence to the information that we have on hand from the slideshow. You can see the RF assembly kind of dictates what the RF set is doing, and then you have the baseband assembly, and then it talks about the antennas. Can everybody see the bottom of this? This is a simple yes or no question, because this part right here is where I explain the less than sign. Who can't see it? That would be a better way of going. Who cannot see this? So everybody can see it, huh? All right. The antennas. This is a little bit better picture. You can see that our 1 foot antenna has 31 dB of gain. Look at the nominal distance. It says maximum. Remember that less than sign that I said was on the 25 miles? So it's also on the 10 miles. And why is that? Well, remember I told you the equipment come from the UK? They work theirs with kilometers and not miles. So when they put this in place, it's 16 kilometers or less than 10 miles. So we work off the imperial system, they work off the meter system, or metric system, excuse me. Then you have the 2 foot antenna. This one is 37 dB of gain, and this one is less than 25 miles, or better known as 40 kilometers. So you can see there is differences. What they're telling you is when you convert 40 kilometers, it is less than 25 miles. Just like when I'm dealing with my LED pixel strips, which come in 5 meters, I know that it's about 16.5 feet long. Why is that important? Well, if I'm trying to run pixels the whole entire front portion of my front porch, I need to know how many pixels are going to go on there, so when I use my program, I can tell it how many pixels are on that front porch. So it just goes to show you, hey, it does play an important fact in there. I'm like that. All right, so I can't remember what I was doing. Right, that, nope. All right, we'll go with that. All right, next up, we have equipment supplied. With this equipment, you can see that we have the 2 foot cable, the handset, the headset. That's what is highlighted there. Again, it's in table 1-3. And of course, it tells you everything you need to know. There's your cable reel assembly. Has the 150 foot cable in there. When you get into the lab room, normally it's set off to the side. If we were in a regular classroom environment and we're going to go outside, I normally have you guys put the 150 foot cable for the very first time to give you an idea that you can separate these two apart. And that's the reason why you have a headset on the RF assembly and the handset on the baseband, so you don't have to yell across the area, especially if you're close to the enemy lines, because the last thing you want to do is be calling, you know, what do you call it? Man, I'm losing my brain here. Calling attention to yourself, because you don't want to be a victim on that one. It just goes to show you another jumper cable. Installation procedures. Now, I highlighted this one to show you that if you're setting up a tripod, it's 1 man-hour. Okay, and normally it's a minimum crew of 2 people. It's 2 people, 1 on each end. The reason why it's 1 man-hour is it'll take you probably about 20 or 30 minutes to go through all the checks, but it's also going to take you some time to tweak the dish to where both of you can talk to each other. And that's where that RSL comes into play. And it's just giving you some overview on how to install the mast. RF assembly, blah, blah, blah. Where are we going? Where are we going? It should be chapter 4 is the next one. And it just goes to show you tripod system with a 1 or 2 foot antenna. Just going through the whole thing again. Come on. Chapter 4. This is where you're going to be able to operate the tisser. When you get into the lab, you're going to be able to open up that book and look through all of the information in how to, 1, put everything together, and 2, how to do what's called a loopback test before you're able to talk to the dissonant. Takes you probably the first time between 30 to 45 minutes. The second time you start getting faster, and that's because you're familiar with it at that point. Remember I told you about the RF assembly and the thumb wheels? It's right there in that highlighted area where it says setting the transmit frequency and also for the receive frequency. Gives you an idea of where to look and what to do. This portion, table 4-1, let me repeat that. Table 4-1 is extremely important for you. Why? Because it has all the assembly controls and indicators, and it tells you what it does. For example, I'm looking at number 1 where it says meter. It says analog meter with arbitrary scale, arbitrary, from 0 to 300. The third meter face is colored green to indicate normal reading on the most measurements. In other words, if you're switching with number 2 with the meter select switch, you're going to hit transmitter power plus 12, minus 12, RSL on the XP. Well, if everything's working, everything's going to be in the green. That's what it's telling you. There's your transmit receive frequencies, the channel error light, and summary alarm. If your summary alarm is illuminating, you got problems, whether it's in loopback or whether you're in operation. This is the baseband assembly, controls and indicators. That's table 4-2. Again, going through each one of them tells you what it does when you put like the meter on, let's say minus 12, is say if it's in the green area, you're good. Then it talks about the summary alarm light. Let me do something here. There we go. Illuminates when a system fault is detected in the operate or standby modes in either the RF assembly or baseband assembly. Light flashes at a 2 Hz rate during normal or during proper operation while in standby mode. If it goes to operate meaning you're transmitting, it should extinguish. Notice that word, extinguish. So again, it goes through each of the LRUs and telling you what each one of these lights is doing and why it should light and why it shouldn't light. Again, this is the operation portion in Chapter 4. Chapter 5, which we're going to go through the signal flow, and if you have any extra time, I suggest very highly that you kind of scan through it. Not saying read it word for word, just scan through it and get an idea how the transmitter receiver signal flow is going to go, because that's where the key to everything is on the transmit and receive. Now, we do go over order wire and intercom as well as loopback testing. We just give you the overview of those. But you can see in Chapter 5, we're going to start with the transmitter operation. And then we give you the C's and D's, or diagrams. And we're going to go through both the transmitter baseband assembly and RF assembly when it comes to putting it in operate. Operate meaning transmitting. We are generating RF going out the antenna. Then we have the receiver operation at 5.3. Again, goes through everything, and we provide you the C's and D's, or the diagrams, where we start with the RF assembly and go into the baseband assembly. So it's the reverse. We do have order wire, but you can notice that it only has basically 2 paragraphs, and loop back is pretty much the same way. We do not cover built-in test. And there is our order wire assembly, and then this is the loop back. And I don't even think the bit test is even in there. So that goes through the part of 4 alpha and all of the tech order. Are there any questions at this point besides, oh crap, what did I get myself into? Questions? Questions?
I get that goes, sir.
C's and D's in tech order on the test. That is very true. It is. You will have the NSM-50 tech manual. You will have the Jerk 239, which we just went over. That will be given to you also, as well as either the, on the disc that you get, you'll have the electronic C's and D's, or you have the option of getting the paper ones. They're in the bookcase when you walk in. They're normally, I think, the second shelf down where the answer sheets are, where the pencils and that are too. So if they haven't given it to you on the way in, make sure that you grab one if you like the paper ones. Me personally, I like the paper. I like to, because I guess when you get older, the eyes aren't very good. So I like to have big pictures. Any questions? All right, here's what we're going to do.